Thank you. And what a great conference. It's got to be the best tech conference in the world right now. It's amazing to see so many great people here. So let's get started. Testing in production. But really, what are we talking about? It's how we make quality software faster. At the end of the day, that's what we're talking about. And it turns out that testing in production gives us a great tool to be able to accelerate our software development and actually produce higher quality software faster. So let's get started. I want you to think about the last feature that you worked on and deployed to production. Maybe a small feature, a big feature, a bug fix. But imagine the last thing that you worked on. You went through your software development process, code reviewed it, felt great, came home, told your family how great this feature is that you're about to deploy at work, answered all the questions from your 9-year-old who knew you were going to save the world with this feature. Is that feature working? Is it working? Thinking about that feature? I mean, is it working right now in production as you sit here? Is that feature working? Right? A few people nodding, a few people thinking. How do you know that it's working? Your phone's not ringing. Who would call you? How do you know they're working? How do you know? Right? Maybe your battery is not dying because your inbox isn't getting spammed with all the alerts from Nagios or Graphite. But how do you really know? And ultimately, if you're feeling a little bit anxious, it's really that feeling of anxiety that we're trying to solve. Like, how can we really, really be sure that the work that we've done is actually working, not just at the moment that we deployed it, when we verified it, but a week later, a month later, a year later. And ultimately, if we could know that our work was in fact done, in the true, I think the broader meaning of the word done. It's working as expected, it continues to work as expected, and we would know if it changed. If we can do all of that, then we can reduce some of our anxiety and then focus our energy full-time into whatever it is that we're building next. And I don't know about you, but when something's not done and I don't know if it's working, like I'm not 100% working on the next thing. I'm just not. There's something in the back of my mind constantly worried. I may flip over, I may be looking at a chart, I may be looking at monitors. I'm not 100% focused on the next thing I'm working out because I'm worried about that thing that I built because it may or may not be working. And if it's not working, I may or may not know. And the dreaded outcome of that is that ultimately we hear from customer service, we hear from our friends, we hear from customers who have our direct phone number to tell us when we make mistakes, and the phone rings, and we realize that we missed something. And it's not a great feeling. And ultimately, this is about what can we do to fix that, to get rid of the anxiety and know that the software that we've built is working. So let's remove that anxiety. Quickly about me. So in 2007, I was the co-founder and CTO of Gilt Group, Gilt.com. Company grew to over 1,000 people. I was approaching $1 billion in revenue. I think 150 engineers working in the company. A few years ago, sold to Hudson's Bay. Started off as a Ruby on Rails monolith. Broke out into a large distributed monolith, 400 plus individual applications, over 1,500 unique code bases, and lots of lessons learned in terms of what it means to operate a distributed monolith or a microservice architecture at scale. And then a couple years ago, co-founded a company called Flow. Flow is an enterprise SaaS software company that we build software that helps brands sell internationally. So just like as Gilt, when Gilt expanded internationally, creating great experiences to sell a product into Canada, China, Australia, et cetera. What was really, really interesting about the journey is you take everything. We had the opportunity to take what we learned about building Gilt, about going to a very distributed microservice architecture, the lessons learned, what worked, what didn't, the 5 attempts at building a staging environment, which we'll talk about later, and 5 failures building a successful, productive staging environment, and then rethinking the things that we wanted to do with the fortune of starting with a clean slate. And ultimately, what we learned, and where this talk comes from, is some of our software practices at Flow are quite different. But first, let's talk a little bit about just software in general. Software quality, it's hard to build quality software. It is a really, really hard thing. A few examples of the highest quality software in the world. One was the Space Shuttle. A few years ago, an article was published about how they write software for the Space Shuttle. And it's amazing. People work 9 to 5. They're steady. When they find a bug, they fix the bug and review why it happened. But then they look at where else in our entire code base could these same conditions exist for this same type of bug to happen. And then they go find all those places and fix all those things. When they're preparing for a software release, they say, well, how many bugs have we found? We found 50 bugs. Well, our data says that on average, every new release has 120 bugs. That means we still have to find 70 more bugs on average before we can release our software, so we can't release. Everybody go find bugs, because we can't release the software until we find the unknowns. That's their process. And they produce some of the highest quality software in the world. It's also the most expensive software ever produced in the world. So there's a trade-off there. Other companies here in the Valley, a few years ago, Salesforce.com, made a huge investment into testing their cloud software and really scaling all of their integration tests across the APIs and everything else. I think that at that time they had 50,000 tests, and if you ran them serially, you'd run them for a decade or something like that. So massive, massive investment into tooling and technology to scale. And we see that same sort of investment happening at a lot of the other companies. You look at Facebook, I think today thousands of engineers work just on software to detect changes in the code review process automatically before they become issues for customers. And all of this is just a signal that it's hard. And then we fast forward to where most of us operate, and of course there's a trade-off between the amount of resources we spend in testing and deploying, and really navigating that balance is tricky. When we think about software quality, a lot of times we think about the software development process up until the point that we push code to production. And here really we just want to make the case that if we really think about the end-to-end life cycle of code, so everything from when a feature and an idea is conceived, all the way through decades later for successful software when that software may finally be sunset. That's the life cycle that we're working with, and we want quality throughout that entire life cycle. And that's important because if we think about it that way, then we can think about what production is, and just be honest that production is a really important part of our lives as developers and as engineers, and that testing in production, which I think has always gotten a bad name, but it's an incredibly powerful technique to help us build quality software. If we could test our software in production, we could prove to ourselves that our software works. And interestingly, it helps us test software in a number of different ways that previously was difficult. Let's talk quickly about software development at Flow. So at Flow, we have true continuous delivery. And by that, what it means is that when you merge a pull request, that code is going to production. There's nothing else standing in the way. You don't merge your code and then have a continuous delivery, continuous integration test run. That doesn't happen. Continuous integration happens before the commit is merged. And it's an important distinction because we wanted to make sure that the process by which we move code to production is the same in standard times when there's no stress, and in urgent times when a bug needs to be fixed quickly. The pipeline is exactly the same. Typical process is a developer opens a pull request, CI runs, we use Travis. When CI passes, the developer has a choice to make. Do I push the green button to merge my code or not? And if they push that button, that code's going to production. We don't have any staging environments. We don't have any developer environments. We don't have any QA environments. We don't have any pre-production environments or any environments like that by any other name. They don't exist. In the very first few months of Flow, it was interesting that we were actually running code in developer environments. And then about 6 months in, we realized that the majority of the engineers were no longer doing that. Those engineers were writing integration tests. And when those integration tests were successful, they felt confident that they could deploy their code. And so it became interesting. We started asking people, well, what is it about the development environment that's interesting? Oh, I want to inspect my code that it's correct. Well, if you inspect your code that it's correct, who's going to be there to inspect your code 3 months later, 6 months later, 3 years later, when we still need to know that it's correct? And so what we did is we removed all of those things. We removed the staging environments, the test environments, the separate people verifying the quality of the code. It's on the developer to make that choice. And now if you're the developer, what do you want to do? You want your code to be in production, but really what you want is you don't want to cause an issue. Great. If you're uncomfortable pushing the button, write some tests. You're still uncomfortable, write some more tests. And eventually you'll write enough tests that you feel comfortable that your code can go to production. And by the way, all those tests are automated. You push the button, your code goes to production. And now, if we've done a good job, we'll come to talk on testing in production. Now we can talk about which portion of those tests are safe to continue to run in production, and let's talk about how we can do that. And so ultimately, we found that we don't run code locally. And that's a really groundbreaking thing, right? We just don't run the code locally. And this is primarily in the APIs. The UIs we write, we still run locally to visually inspect. But everything else is the same. If there's something that you want to verify, that we want to verify, we write the test. If the test is hard, it's going to be hard for my colleague. figure out how to make that test easy, invest in that tooling so that we can gain comfort, and then we can deploy software to production. Let's talk a little bit about true continuous delivery. So last 2 years are the first part of my career. I started writing software in I guess professionally in '96. So it took almost 20 years to get to a point to experience continuous delivery. And it's amazing. It's better than anything anybody ever tells you if you haven't lived this way. To actually know that when you merge something, it's going to production all the time, safely, repeatedly, is a fantastic way to operate. Because when your deploys are really that simple and reliable, it opens you up to lots of different ways to producing code. One is, what does it do? So if we think about developers, and we're all people, and we think about the psychology of people, right? If we want all of our, I include myself, if we want our engineering groups, if we want ourselves to really invest the time to write good automated tests, what do we need to do? Well, one technique is you remove the safeguards, right? And you depend on people wanting to do the right thing. And that really works. If really the only way that you know that your software is going to work in production is if you write the automated test, guess what? You're incented, you're motivated to write a good automated test because you want to know that your stuff works. Assuming continuous delivery in the design process. So this is also pretty interesting. But if you know that it's very, very simple to release software, then at the end of the day, you can release software all the time. And we talk about small releases. We've been talking about that for a long time. And lots of organizations are doing it. But now we can talk about things like configuration. If you can release software just by pushing a button, can a configuration change be the same as a software deploy, as a code change? Why do they need to be different? And if you can actually manage your configuration changes in the same way as you manage your software changes, guess what? It's the same visibility. You make a configuration change, all of your tests run, you click the button to merge the PR, it goes into the delivery pipeline, and it goes to production. All of the notifications you probably have for changes in production continue to work. All of those neat monitoring systems that tell you that a deploy happened continue to work. If you want to see what happened in a deploy, you can see that a configuration state changed. And all of a sudden, we're managing change in our environment exactly the same way. And that notion of seeing things exactly the same way is also critical to operating, I think operating this way, or maybe just generally operating in an excellent way, where we really, really know what's happening. The screenshot at the bottom, so at Flow, we wrote a small tool called Delta. It's open source, github.com, FlowCommerce Delta. And it is our continuous delivery engine. What it does is it listens to webhooks from GitHub. It knows how to build Docker images on Travis. And it knows how to scale clusters and inspect the health of clusters on, we use AWS ECS. And then it just gives you this dashboard that says, OK, I saw something new on master. I'm going to go ahead and create a new tag for you and get it safely into production. Very, very lightweight tool. It took about, I think it was a week and a half of development effort by one of the developers at Flow to get this up and running. But the key thing was to really have the process in place that we can have continuous delivery in place to support the other deploys at Flow. So let's talk about staging. I love my staging environment. Said nobody ever, ever. But let's do a quick poll. Hands in the room if you love your staging environment. Prove me wrong. Pretty good, pretty good. I'm going to call that at 1%. So that's probably 8 people. When we think about staging environments, what does this? Staging environments feel great, right? Like we have a place we can deploy all of the changes, or just our change, and then we can visually inspect it, or we can have another team run through scenarios to test and verify what's going on there. As we move into, particularly as I think we move into these microservice architectures, a few things start to happen. One is that the staging environment changes during the testing. Otherwise, if it takes 12 hours or 24 hours to verify something, you're doing one thing at a time, one thing a day, and it feels slow and inefficient. Second is that actually it's very difficult to treat a staging environment as a production environment. And what that means is that if some service that you depend on for your test that's run by another team becomes unavailable or unresponsive or doesn't have the appropriate data or hasn't been updated or is out of memory, maybe an alert goes off, but probably not. And that person won't respond in the middle of the night because it's staging. It's not a production issue, and it's not treated as such. And without that, what that means is that staging becomes unreliable. And more than that, it becomes unreliable in a way that we don't know how to fix it because it's someone else's stuff that's running there and broken. As an analogy, I remember when we were doing in the early days, Facebook introduced this pretty cool feature where you could log in with Facebook. And it was the early days of the feature. And we integrated against it so that you could log into Guilt through Facebook. And at the time, we didn't go to Facebook and say, we need a copy of all your code to run on our sandbox environment so that we can test the feature. We didn't do that. Yet, when we're testing login against our own internal services, against our authentication service or user service, as it was called at Guilt, we go to that team and we say, please give me all your code because I'm going to run it on my staging server to prove that I can log in. And so there's a difference, right? And that difference is interesting and worth exploring, why we're treating our internally developed software different from the software that we're using out in the ecosystem. Let's talk a little bit more about staging environments. So they're bottlenecks. Many organizations start off with one, and then you get into a distributed architecture, and you say, OK, payments team, you have your own staging environment. Checkout team, you have your other one. Login team, you have another one. Front-end team, you have another one. And now you have lots of staging environments. And then what ends up happening is they have disparate failures, and sometimes they work, sometimes they don't. But teams are under pressure to get their features released, and so they start hacking them to get to the point that the staging environment is consistent enough that they can test the one feature that they need to get out to prove to themselves with some reasonable certainty that if that feature goes to production, it's going to work. And even if they do that, the feature goes to production, does it work? Sometimes, most of the time, but there's still bugs. It's not 100%. Staging environments are fragile. When they fail, they're difficult. Recently, I was debugging a staging environment during an integration with the client, and the staging environment wasn't working. The way that I debugged the staging environment is I wrote a small Ruby script that went and found all the log files on the system, and every 3 seconds showed me the top 5 that changed the most. Because I knew nobody was using the staging environment, and I knew that those log files that were growing were probably errors. And sure enough, I went one by one and killed the servers because they were not able to start, and they were hogging all of the CPU in the staging environments. That's insane. Can you imagine doing that in a production system? The key point is that those services weren't required, and it required other teams who weren't involved on our work to participate to make the system stable. And that is a very, very expensive proposition, and I think this is at the heart of it. The organizations that I've personally seen, and there haven't been many, where staging works, commonly invest over half their budget in staging. Most organizations I see invest 20 to 40% of the budget. 30 to 40% is pretty common. But those are the organizations that have, I'd say, dysfunctional staging environments. It requires a huge, huge investment across the organization to make it work. And then arguably, I would say in today's day and age of a lot of automation, perhaps staging creates the wrong incentives, where staging is asking people to spend time to do things over and over again without automation in most cases, right? Because you don't need it. If you have a staging environment, you can inspect and you can release. And so our incentive to write the automation goes down. It's hard to write good automated tests. It's hard to write automated tests that are repeatable. And by the way, if we have this fail-safe to just say, deploy to staging and have a few people look at it, we'll take advantage of it. We touched on this a little bit, but if you remove staging and you still want to have good production quality code go out, then the question really boils down to your tests. And at the end of the day, this is super, super powerful, right? If you're not comfortable that your code's going to work, write some tests. You're still not comfortable, write some tests. You're still not comfortable, write more tests. Still not comfortable, write some more tests. And eventually, if we do that, what we find is that we start to trust our tests. That we can trust that if our tests tell us that our code is good, that we can deploy to production. And by the way, if we do this, lots of other things start to come into play. One of the practices that we have at Flow we call Dependence Day. Dependence Day. And Dependence Day is that we just decided that all of our stuff is going to be on the latest versions of everything. Our own code, our own libraries, the open source libraries that we use. We upgrade AWS every week because they publish like new versions twice a week. We're always on the latest versions. And we do it through Dependence Day. And what Dependence Day does is it finds all the versions of everything that we use, and it submits pull requests automatically to all the services. And when the build says green, you merge. And you deploy that change to production. And we can do that. And now all of our services are current. All of them, across the board without exception, are on the latest versions and the same versions of all of the libraries that we use. And if you think about it, it's amazing, because now if you need to do something else, you can, because you don't have to worry about version mismatch or upgrades for services that have been 6 months old. I want to touch briefly on architecture. So quality through architecture, I think, is super, super important. And there's a few elements here, but one is just this idea of extreme isolation. So as a developer, if you deploy something and you break something, you probably know what it is, and you iterate pretty quickly, and you fix it, and probably the impact on the business in most cases is small because you've moved so quickly. If you receive a page and your service is not functioning because something else broke your service, that's hard, right? And it's powerless. You're powerless. Like, how can I run a reliable service if anything out there can break my service? And one of the approaches to fix this is what we call extreme isolation. Extremely isolate your service from everything else. Services that flow have their own DNS. They have their own load balancers. If they have a database, that database is private. Nobody else is allowed to talk to it. There is no shared state. There's no console. There's no zookeeper. There's nothing. There's no shared state. And we really focus on this stopping cascading failures and preventing the chance of somebody else to cause an issue in your service. The services are extremely isolated. And initially, as an engineer, you come into this, it's not totally efficient. We can just have one load balancer do this for everybody. The cost is not in how the extra incremental dollars running the load balancers. It's really in understanding failure and understanding that failure is not caused by other people so that we can, again, trust our services and drive quality. One other small detail, there's a lot of talk about event streaming. And what we found, interestingly, at Flow is we have built a pretty sophisticated data architecture that's really based on event streaming. So every microservice publishes events, and other microservices consume those events. And what ends up happening on the network is our microservices don't talk to each other. The network is very, very quiet. Instead, they consume data through the event stream. And there's only a handful, and it turns out it's quite rare, of use cases that really require the services to be synchronous. And yeah, those guys will go talk to each other. And if in e-commerce, if you submit an order, you want to make sure that you have payment for the order, is an example of a synchronous transaction. But it turns out those are the minority. Everything else is asynchronous, right? So there's microservice architecture, but there's no traffic between the services. And the reason we did that is, again, a cascading failure. If I'm a service and I depend on you and you have a hiccup, I don't want it to affect me. And event streams really give us that. I can listen to the event stream, and if you have an issue, the problem in our business is a slight delay in receiving the data through the event streams. And that ends up being a much easier thing to manage. But I think the main thing to really focus in on here is this notion of extreme isolation as we architect and build our systems to reduce the dependencies that can cause issues on us in terms of quality or uptime is an incredibly powerful tool. So let's look at a few real examples of successfully testing in production. One, we did a Gilt e-commerce system. You want to know that the submit button works. Right? Can customers buy stuff? Ends up being a pretty important KPI. But how do you do that? You place an order. You're probably decrementing inventory. You may be charging a credit card. There are a lot of bad things that happen. And so it turns out that I think the common use case would be you test in sandbox, and then you deploy to production. And maybe you set up an alert that says, if I haven't seen an order in 5 minutes or 10 minutes, maybe something's wrong. It's kind of status quo. But what if we rethought this and said, you know what, let's just go submit an order every minute, every 5 minutes ourselves, actively. Let's actively submit an order so that we know it's there. What would have to happen for that to take place? So what we did at Gilt, and actually this was driven by our mobile apps, because initially our mobile apps, as we built the iPhone app, it couldn't communicate to our VPN environment, which is where staging was. Talk about friction for developers. You want to test a change, you got to make your staging environment work, you got to debug it, you have to use this VPN crazy thing, and then now you have an iPhone app, and now you have to configure your iPhone app onto a VPN, and that's what our developers are spending time on instead of building automation and building features. So what do? We said, OK, let's think about this. Why don't we find a way to identify a test user? This is great. We can even know that registration is working, right? Register a test user. You can even log in now. We have a test user. Oh, great. Now registration is working. Login is working. We can browse the site. We can put something in our cart. We can get to checkout. We can submit an order. And interestingly, all we had to do is agree. We identified test users by a domain name. I think it was gilttest.com. Any user at gilttest.com, if you place an order on gilt.com, your order will get canceled. 3-line change in order processing. 3 lines. If user.emaildomain equals gilttest.com, order.cancel bang. It's a Ruby app. That's it. And now we can run automation every few minutes, go through the funnel, place an order safely. Yes, we've claimed inventory, but we've claimed inventory for 5 minutes, right? And we can now start dissecting those problems. Oh, claiming inventory, that seems like such a bad thing. Well, great. Well, why don't we shop for an item that has a lot of inventory? Cool. So we'll add a little web service that says, tell me the item currently in the catalog that has over 1,000 units of inventory available. And let's go buy one of those so that there's plenty left for customers. And this is a really simple thing. And now we can write an alert that says if we don't see an order every 3 minutes from our test user, or if that test user gets an error of any kind submitting the order, that's a very high fidelity alert that we have a problem in production, right? And now we can take the learnings from that. We can investigate faster. We'll start faster. And nothing else changes about our process. Let's understand what happened. Let's understand how to learn from it. And now let's get better at what we're doing. Interestingly, when we look in e-commerce, there's a lot of subtlety about inventory and locations and things like that. What's super interesting about this technique is let's say that we found that it worked for all orders shipping to the US, but there was a problem shipping orders to France. Great. Now we write 2 tests. Let the user go through production, ship something to the US. Great. Now have the user go through and ship something to France. Now we're running both tests, and we can verify forever that this is working and know that the instant there's a problem, we're going to be notified. So this is a hugely, hugely powerful thing. One other small thing that we did at Gilt, load testing. I was talking to somebody before this talk about load testing. And actually, the good folks at Zalando. Load testing in production is amazing. It's amazing. Not saying that you shouldn't do load testing in other places, but load testing in production is amazing. At Gilt, if you think about Gilt's use case, so really Gilt's whole business model was every day at noon Eastern, a new selection of inventory went on sale at great prices, and everything sold out. And we saw a 50x traffic increase between 8:59 a.m. PST and 9 a.m. PST, 50 times traffic. And in the early days of Gilt, 80% of our revenue happened between 9 a.m. and 10 a.m. Pacific time. What do you think the cost of an error is between 9 a.m. and 10 a.m. Pacific time? It's high. What if we do a load test at 1 a.m. Pacific time, when traffic is super quiet? And if we identify a problem at 1 a.m., we've got, 8 hours to fix it before it really matters. And it was super, super revealing, and it feels scary. But the first time you do it, you do a load test, and probably things fail in production. And they probably passed in staging, by the way, or in your pre-production environment. That's what we learned. And then we fix them. And then we run the load test again, and then we fix it, and then we run the load test again, and then we fix it. And then every single day, the load test runs, and the day it breaks, we find out 12 hours before it matters, and we have a chance at protecting the revenue for the business. Overall, from a system perspective, the overall system is much, much higher quality when we're doing this. We'll switch back to Flow. So Flow is a software as a service business. What this really means is it's a multi-tenant data architecture. If you sign up with Flow, we'll give you a unique organization ID. And that organization ID is for your production data. And then if you want to write tests, you can create as many sandbox organizations as you want. The only difference in a sandbox organization is that they have an attribute named environment, and environment is sandbox instead of production. That's it. And now you can do whatever you want to do with your sandbox organization. In fact, we have clients that did, when they wrote their integration test with Flow, step 1 of their integration test, create a new sandbox organization at Flow. Now run their series of tests through the API and their integration. And when they're done, delete the sandbox organization from Flow. And it's an incredibly powerful technique, because by doing that, when they create the initial sandbox organization at Flow, it's an empty shell. No human or bot or API came in and created data or changed data. It's empty, and because it's empty, it's reliable, right? So they can create this organization, they can create their product catalog, they can do all the things that they need to do, they can place some test orders, and they can delete it. Now, what makes it safe? So at Flow, we said we wanted to offer sandbox accounts. So now at Flow, we have to think about what are the things that are dangerous. And dangerous in our world really has an effect in the real world. We do payment processing. So charging a credit card on a sandbox account, probably not the greatest thing. And so we have in our payment system, there is a branch of code that says if this organization is sandbox, then use the sandbox processor. And the sandbox processor is a no-op. It does nothing. It happens in fulfillment, and we do things in logistics, printing shipping labels. We want to make sure that you don't get charged for those if you print a shipping label for a sandbox organization. But that's it. There were maybe 2 or 3, maybe 4 examples in an end-to-end e-commerce system where things actually had a negative real-world effect. So what did we do? We made sure that those systems understood what the sandbox account meant, Turns out that's really, really easy to unit test. Create an organization, make sure that payment works. Create a sandbox organization, make sure that payment doesn't go to a third party. Bulletproof unit tests. We can deploy it to production. And now every single client of ours can use sandbox accounts. There's a detail here about one API key for all sandbox accounts. And this is something that we just learned at Flow, where when our clients were integrating and they want to create a new organization, one way to do that is you create a new organization, and then you have to get a new API key. We just made sure that their same API key would work for all of the sandbox organizations that they're running. So every hour when they run their integration tests themselves, they don't have to change their environment variables for talking to Flow. It's a small detail, but one API key to run these integration tests. The learning here is to treat every service as a third party, whether it's internal or external. And it's a really, really powerful concept. So back to Facebook and Facebook login. We don't ask Facebook to host their code to run it. We just test using Facebook's APIs. And they have test APIs or sandbox accounts. Payment processors like Stripe give you a test account and a production account, and we use that. We don't ask Stripe that we're going to run all your code on our infrastructure to test. And this same concept turns out to be relatively straightforward to apply to the own software that we're writing internally if our teams develop a contract and provide for it. Here's a live example of an integration test that we run regularly. This now runs once a day. Travis has a cron feature. I think the most frequent in Travis is once a day, so this runs once a day. This is a little Ruby script using the Flow API to go and create orders. And this basically says order equals create order, some parameters, different countries. Then go create a payment authorization using a credit card token. And then go ahead and capture funds against that credit card authorization. And you can see the history. It runs about once a day. So this is a really nice test. It runs once a day. If this fails, we know immediately that there's a problem. And we've invested the time to make this test reliable, which is worth saying. First time this went to production, I'd say it took us about 3 weeks until it was green every day, because we uncovered issues along the way. Right? We ran out of inventory or whatever, normal validation issues. It took us about 3 weeks. Not 3 weeks full time, but every few days there's a new issue uncovered, and then we fixed it until the point that this thing runs every single day. And I think now we have about a year that it's just stayed green. We know every single day we can accept orders and process payment. Super, super powerful. We know that when we deploy changes to our payment system, we can trigger this build and make sure that these tests continue to work against the payment system. We know when we deploy our API proxies and change API routes, we can run this integration test and know that the heart of the system continues to work. It is incredibly calming, I think is the word, to know that things are working as expected. Here's another example. So at Flow, we wrote our own reverse proxy, which is api.flow.io. And it makes all of our microservice APIs feel like one, handles authentication, handles weird things like JSON-P and request envelopes, a whole bunch of other stuff. This is a critical piece of infrastructure for us. If there's an error in our API proxy, all of the APIs become unavailable. Right? So this is a central point of service. Earlier, we talked about extreme isolation in our services. The API proxy, in our case, ends up being the thing that has no isolation. Like, this thing goes wrong. It is a cascading failure across Flow. It's an emergency. But by virtue of knowing that this works, and it's a relatively small piece of code, then we can really drive extreme isolation for all the other services. So now when we make changes to the proxy, it's dangerous. How do we test those services? Proxy has its own tests, mind you. But how do we really know that a configuration change or a new feature continues to work? So here's an example of what we do. This is running AWS profile. Go grab our configuration for the AWS account Flow Vault, which is where is our PCI environment. Dev is a Go script that our developers use that handles everything for developers at Flow. Scala app, so SBT, and production. So go get the production environment for the reverse proxy, but run it locally. So now I have on my laptop running our reverse API proxy, talking to all our production services. And then I can run tests locally. And instead of hitting api.flow.io, I'm hitting localhost 7000. And then capture the output that the test passed. And these tests do all sorts of things. They're basically for all the features that we add into the reverse proxy, we add a little test to verify that it works. If you mistype something, is the error message good? If you're doing JSON-P with a complicated URL string, does it get parsed correctly into JSON body and forwarded to the right service or the right response codes? All those things. And then we can run it and verify it here. We do this all the time, right? Because now, even before we touch production, we can have the latest version of the software running. We can run all the tests. And now we can do everything else that we do. Great, all the tests pass. Let's deploy it to production. In fact, let's deploy it to one node in production, a canary. Great. Now that the canary is running, let's run the test against the canary. Great. Let's monitor the canary. Is everything working on the canary? Yes. Let's roll out to the rest of the cluster. Let's run these tests again. And by the way, we can schedule these tests and run them every single day as well and know that the proxy server is working. One other side benefit, reverse proxies have a lot of features in them. And it's interesting to think about the complexity of our test code. Some tests are hard to write when you're inside the code base, and much, much easier to write when you're inspecting externally. And API proxies end up being one of these things. It's very easy to just talk HTTP to a server and check what the HTTP response is. So actually, by introducing this way of testing, we were able to simplify the tests that run against the proxy. And ultimately, this is what we're after, that everything is operating as expected. And if it's not, that we would know, right? Alas, sometimes things go wrong, even to the best of teams. He hasn't quite yet mastered the art of the diving header, this one says. And so let's talk a little bit about how we handle that and what some of the considerations should be. So one is that we make production access explicit, not the default. Right? So we really think about this, and we think about this from the beginning, from the design phase as we're building the next feature. Like, let's think about, from the start, how are we going to write tests that run in production once this feature is live? Or said another way, if you imagine you're about to deploy a change, once that change is deployed, great engineers will go verify in production that it does the right thing. Right? They'll go look at it. Well, now think about, how can I automate what I would verify? Can I do that? Can I write a script that's going to automate? And if I can, great, because now I can deploy my software, I can run my verification script, and if it succeeds, great, I can think about scheduling it, and if it doesn't, I can quickly roll back, probably faster than I could before, because I've already thought about from the beginning how I'm going to verify that my software is working. Second is to use defined paths. If you have an API, use API calls. And this is as opposed to just reaching into a database in production and changing some data to enable some use case. The idea here is to really use the defined paths. However your software works in production, use that. Don't invent a new way. Use that. There's a classic, I think a classic case, I'll call it a case, is what do we call production event. A friend of mine was describing, and they were approaching their peak season, and they said, we got to have more servers, and we should deploy less frequently, and maybe do a code freeze or something like that. And so a week goes by, everything is fine, and week 2, things start crashing. And it turned out they had a memory leak for years. But because they're continuously delivering their software, it didn't matter. And they changed their mind. They changed how they were managing production, and new issues surfaced. And that can happen here. And so I think the solution to that is to really not change the way we work with production. We work with production in a very certain way. Let's be conscious of that, not change it. Work in that way. And then iterate slowly and deliberately. Sensitive data comes up quite a bit. HIPAA, PCI, PII. There's new regulations in Europe. And I think just thinking about these things up front is just important. Here we showed you an example of a production test that was actually creating credit cards, verifying credit cards, authorizing, capturing funds. You could do it. It absolutely works. In our case, the solution here is just to use a test credit card and make sure that that test credit card was threaded through. But it's just worth flagging and thinking about from the beginning. And designing for side effects. There are lots of side effects. There's side effects all the time. The common ones that people run into are things like, I'm running an A/B test, and now all of a sudden I have all these test orders. What just happened? Are my A/B test results valid? Things like that will happen. And just good to think about those up front. The two broad solutions are either cleansing data, right? You've created the data, you know what it is, you can cleanse it. Or 2, making sure that your own data that you're injecting is random and normal. And if it's random and normal, then in general the impact for those sorts of things is factored in. It's negligible in terms of an impact on the business. I want to touch on a few unexpected benefits of testing in production. One is what we call perfect documentation, really perfect. So I hate, as a developer, going to a doc site, cutting and pasting the example, and then having it not work. It's infuriating. So the way that we solve that problem at Flow is we actually just capture the request and the response as part of our production testing. Right? We're testing this stuff all the time. So why don't we just add a log to our tests that captures the request that's being sent, captures the response. At the end of the regression test, if it's successful, it uploads that to S3. And we have a tarball with all of our examples. When we release our documentation site, it downloads the latest tarball and pulls the examples from that. right? So we know that the examples are real because they're real. And this is just an example of that. So quick curl command on the left, we captured the request that was coming in. On the right, you can see the output. We have a very organized file system. It's a RESTful API. And so resource/method/path, and then response.json, request.json. This is actually the contract for our documentation site. We produce a directory. We tar it. We throw it in S3. And it has a standard format so that it can get merged into our documentation. It's amazing. Second, I think great demos. So we are an enterprise software company. We do demos. One of the things we like to demo is our analytics page. A long time ago, our analytics page had no data because nobody was using our demo store to buy stuff. So what do? The earlier automated test that you saw that runs and creates a few orders, it's actually using our demo account. And that straight line that you see, every day it places 10 orders. And so it's been 10 orders. The spike that you see, that's me just getting some more data for this talk over the last few days. Right? It went up to 30 because I must have run it a couple extra times on November 11th. And on November 12th, I ran it an extra time. Real data. And now we're done. Every single day, we're producing data. And now we get to use it for a demo. It's great. It's real. I want to touch a little bit on tooling. We depend a lot on something called apibuilder.io. If you're familiar with gRPC and Swagger and things like that, think of, and GitHub, I don't know how best to describe it. Think about API Builder as like gRPC for JSON, where JSON is truly, truly first class. Some people have said API Builder is like GitHub for your APIs, where it gives you incredible visibility into your changes, what's breaking, what's not, incredibly high quality mocks and clients. And so what's actually happening, and this is really, really important because ultimately, to make some of this stuff work, you have to really trust the contract. If you have a microservice architecture with a lot of APIs, you really need to make sure that different teams trust the contracts that the other teams are publishing. If you're using gRPC in your binary land, that's probably already the case. If you're in JSON and using some of the other tools, that probably is not the case. That the published documentation or specification of an API matches what's actually in production. But it's really, really important to have that. And so anyway, API Builder is something we started at Guild 4 or 5 years ago. It interops with Swagger and Avro and some of the other things, but provides some really, really nice tooling. We do a lot of mocking at Flow in our integration tests and also at Guild. And here's an example of what API Builder provides. So what you can download from API Builder is a mock of an interface of any one of the services or the event streams that are flowing. And that mock, we use Scala, so that mock compiles. And it knows how to generate valid data. And then what you can do is very easily just override the parts that you want. And so an integration test is an example that this is a geolocation test that basically says, for this IP address, return the address that I want. The code on the right is all we had to do in terms of the mock to know that it works. And because the contracts are guaranteed to be correct, we know that if the mock passes, it's going to work in production. And actually, our experience over the last few years is that this has been the case. We don't have situations where things work with the mocks and then fail in production. And the only caveat to that is authentication. But it has never been the case. So we can trust our mocks to that point because they're generated in the same way that our clients are generated, that if our tests, our automated tests work against the mock, they will work in production. So that's API Builder. We use this tool called Vivid Cortex on the database side. Incredible real-time feedback on what's happening in your databases. And in this particular case, it's just highlighting an index was created. Very quickly, you can see that a query did not improve, and then queries 4, 6, 7, you see the variability in response time. Those queries got slower. But the important thing here is on the data side to also have responsive real-time feedback in terms of what's actually happening, so that if something does happen that's unexpected, we know right away. Vivid was a tool that was introduced to about a year ago, and it's proven to be fantastic and has made it into the, I'd say, daily developer tool chest at Flow. Earlier today, the talk prior, Sarah mentioned the importance of consolidating logging. We also, as one of the early things we did, couldn't agree more. She uses Splunk. We use Sumo Logic. But at the end of the day, every single log file from every single service goes into a consolidated view that is fully searchable. And then within here, they have kind of a nice tool set to define alerts. So in real time, anything matching this query, deliver it to PagerDuty or deliver it to an email. And what this means from a developer perspective is that all the developers, as developers have to do is just log things in our applications, and somebody else is responsible for getting those things to us. So a few key takeaways. One, trust your tests and run them in production. Maybe not all of them, but run a subset in production all the time. And then to come back to the beginning, we'll know that the software that we deployed is working, not just when we deployed it, but today. Continuous delivery, invest in it, leverage it, fantastic. For all the reasons of we know small changes, easier to know what's happening when something's not happening as expected, fast rollback. But also it just changes the way that we design our systems in a fundamental way. There are plenty of techniques to invest in. So we talked today about sandbox accounts, mocks, but there's lots of techniques that we can use to improve the quality of our automated tests so that when we reach production, things work as expected. And finally, just instrumenting production for real-time feedback for the cases where things don't go as expected. And with that, I think we have just a few minutes for a few questions if you have them. And thank you.
So thanks for such an inspiring presentation. And my question is, how do you test your data migrations? Do you test it in production?
Yeah. So the question is, how do we test our data migrations? Interestingly, on data, what we found, well, first of all, how many people write rollback scripts for their data migrations? Is that like a practice? You guys are all wasting your time. Stop doing that. It doesn't work. And if you don't trust me, think about the last time your rollback failed. Probably because the data in production had a different network latency, or the data size was bigger than what you tested it on. And you've just created a crisis. And that crisis is amplified because you thought it would work, and you're not prepared to deal with the consequences of it not working. So frankly, my suggestion on data migration on that side, if you're really going to go with a rollback strategy, you have to have a cluster of data separate that you can practice on that has the same size and characteristics and same load as you have in production. And if you figure out how to do that, I want to come to your talk, because I don't know. What we've done at Flow and at Guilt is we decided that you cannot have a breaking schema change at the data layer, and also in the event layer at Flow, you cannot do that. You just cannot. That's cultural. We just decided you don't do that. So what you have to do is make small incremental changes, and we have no automation around it. When you deploy your database change, you're actually logging in to a production server, and you're applying that change. And we try to do that. You've gone through all your testing and everything else. You're obviously in a position where you think this is going to work. You've run your tests ideally against both versions of the schema. But when it comes time to applying it, that process is fraught with peril. And so we actually remove safeguards. It's a human process. You're doing something that is dangerous. Let's put ourselves in that mindset and then be as careful as we can and be as responsive as we can to come back. That's what we do. I think it works in practice. I wish there was a better answer, but at the end of the day, that's what we found for data. And I think, yes, sir.
Hi. My question is that many times you run into problems with the data which is coming in the production servers from the users. So, and it's sometimes hard, or you're not expecting to write tests for those kind of data. It's something unique about a user or an environment, something. So have you thought about anything using real production data and using your test with the data or something similar?
Yeah, it's a great question. So we do a couple things with production data. Number one, actually this is great. This is amazing. It just went into production, so I'm super excited. Our API proxy receives a request, forwards it to the back end, receives the response, and checks the status code, the HTTP status code. It then looks up the expected status codes against the API builder specification for that API. And if the return response code is not expected, it logs a very verbose warning. Actually, it's an error now. It triggers pagers. It says, I got this request, and the service returned a 202. I was expecting a 201. And it logs it. And we have a library that does very good sanitization of data, again, based on the API builder specifications. So now what happens is when that happens, a pager goes off, and we've captured the request data from the client and the response data from the server in a secure way. So we can actually usually diagnose the issue immediately. Now, step two is now we have to decide what to do. For sure, we're going to put that into a test. We have a practice that when something happens in production, we write a test somewhere, right? It might be a test that runs in production. It might be a unit test. It might be an integration test. We don't care, but write the test. And then second, in some cases, we've built tooling to say, go back out and get sample data that was interesting, and then run regression tests over that. And that ends up being a pretty interesting way to converge pretty quickly. Great.
Sorry.
Where should we go?
Here.
Justin. Yes.
Yeah, sorry. You mentioned that you're starting with a clean slate from Guild to Flow. Do you see any kind of restrictions if you're not starting with a clean slate on from that infrastructure? So
it's a great question. I'm going to rephrase that as, have you learned anything with the Flow experience that could have helped in the Guild experience of migrating to this sort of development, given the parameters of a very successful company with everything that comes with that, right? So there's a few things. One, continuous delivery, like really, really nailing continuous delivery. Two, actually having one way to do things. So I didn't talk about this here, but at Flow, we've decided we have one way to do things. We have an event processing pipeline. Somebody came up with a better idea and improved something. Somebody else has yet another idea. That person has to wait. We've got one idea in queue. Either we move everything to new idea, or we discard new idea and go back to the way that we were. We have one way of doing things, and we only adopt one other way. One of the mistakes, now I think mistakes, in hindsight, one of the, I think, mistakes we made is we had multiple ways to deploy code. We had multiple ways to provision code. And those things start to pile up. And today, in a world where we have containerization and Docker and all the tooling that's available in the clouds, there's no reason for that. There should be one pipeline to production that handles all of the variety, almost all of the variety of the services that we're writing. And it's a huge, huge point of leverage. And then finishing it, like really finishing it and being disciplined to finish it, and not getting distracted by whatever it is. We have a huge opportunity, a new partnership, all the shiny things that drive revenue for a business. Just to have the discipline that somebody stays focused and drives those things to conclusion. So again, we have one way of doing things and really understand how the business works. I think have been huge things. And with that, we're out of time. I'm happy to take a few questions after, but I just want to thank you for joining us today.